solar storm. In 1859, an amateur astronomer named Richard Rickerton clamped the star to his private observatory near London. He adjusted his telescope and projected an image of the sun onto a screen. He was looking at sunspots, area of the sun that appear darker because they are slightly cooler than the surrounding areas. Suddenly, two patches of white light appeared around one sunspot. Before dawn the next day, spectacular display of red, green, and purple light, known as auroras, lit up the sky as far south as Panama in Central America. In the eastern United States, people were able to read newspaper outside in the middle of the night. Further west in the Rocky Mountains, the light confused campers enough to get up and start cooking breakfast. Some people even thought their city had caught fire. What Carrington has observed was a solar superstorm, a massive eruption on the surface of the sun sent billions of tons of electrical and magnetic matter hurtling through space. It even causes damage here on Earth when the matter collides with our planet's magnetic fields. It causes electrical current to surge through telegraph lines, disrupting communication. No solar superstorm as powerful as the 1959 even has occurred since. That's why scientists find it difficult to calculate the impact a similar storm might have on today more wide world. A hit came in 1989 when a solar storm, a third less powerful than a Carrington event, causes 6 million people in Canada to lose power. A Carrington-class storm could leave millions without light, drinking water, sewage treatment, heating, air conditioning, fuel, and telephone survive for months. Few objects seem as familiar as the sun. There it is up in the sky every sunny day, yet few objects are so strange. Look through a solar telescope and the sun in transform streams of light, the sign of planets, right into black space, only to come back down hours or days later as if controlled by some unseen force. Neither solid, liquid, or gas, the sun is made up of plasma, the fourth state of matter. Scientists are learning more about the sun and how solar storms form. The sun is packed with magnetic fields, some emerging on the surface as sunspots. They help to power the solar wind, sending a constant stream of particles out into the solar system. The fields can also become entangled with plasma, forming gigantic loops that are illuminated by the hot glowing plasma. When loops cross, they cause the enormous plasma eruption known as solar flares. Solar flares, Such flares release intense energy into space,